Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1358, number of substrings containing all 3 characters. This is a medium difficulty Leetcode problem, and in this problem description we're told that given a string S consisting only of characters A, B, and C, we want to return the number of substring containing at least one occurrence of all these characters A, B, and C. So we're given some examples. In this first example, we can see that we have a string and the output is 10, and the explanation we're given is the reason we're returning 10 for this input is because the number of substring containing at least one occurrence of the characters A, B, and C are the following characters. And what's important with understanding how this problem works is once we find, let's say at the beginning we have A, B, and C. So now we've found at least one substring that contains all the characters A, B, and C. So this satisfies the condition. Well, it means, adding any more characters to the end of this substring doesn't detract from the fact that these are now all also valid. If these were all, I don't know, it was if we had A, B, C, and then H, 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 this would still be a valid substring because it would contain A, B, and C. And so this is something that we also need to factor in when we're solving this problem. So what kind of pattern does this problem indicate that we need to use? Well, this is a sliding window problem, and it's a bit of a textbook sliding window problem. You can kind of spot it from a mile away, but the logic that I just mentioned and the condition where if you have a substring, all the following substrings will also be valid because they will have contained A, B, and C. And so let's actually code the solution for this up in Python. The first thing we want to do is create a counts map, and because we're using a sliding window, as we go through the string, we will add and remove characters from this hash map as our window expands and shrinks. And then we want a result variable. And then we can say for r in range length of s, we will let's take this to counts. Okay, so counts equals counts dot get sr, and actually this should be counts sr counts dot get sr 0 plus 1. There we go. And then we want to say while the length of the length of counts is equal to 3. So while we have a valid substring, we want to increment our result. And you might say, well, let's increment, the result by the size of our current window. So let's do, r minus l plus 1. But this is invalid because, and the reason it's valid is because we want to not just count the current window, but we also want to count all the substrings that start at the current left pointer and extend beyond the right pointer. So they will all also contain the 3 characters like we discussed. So instead what we want to do is say we want to say result plus equal the length of s minus r, and this will give us our current substring, our current window substring, but also all the substrings that will come after it. And then we can say count sl minus equals 1 because we're going to be shifting our left pointer, and if this equals 0, we're going to delete it so that we don't have it sitting there, and otherwise this condition here won't pass. And then once we finish from our while loop and for loops, we can simply return our result. let's actually submit our code and check it passes all test cases, and we see that it does. We see that it passes all 54 test cases for this problem. The time complexity for this problem is big O of n, and the space complexity is big O of 1. So I hope you guys enjoyed this video, and I'll catch you in the next one.